Okay, this is the 4-1 to 4-2 review. Calculators are not allowed, and it's number 5. Our job is to write the equation of the tangent line that is parallel to the secant line created by the interval endpoints. So that means we're writing equations of lines, which means we need points and slopes. And we're going to find the point after we determine the slope of the secant line and then set that secant line slope equal to the derivative. So we don't know the point. We don't even know the slope yet, but we can find the slope because it will be f of b minus f of a over b minus a. And this is going to be the case for all three of these. So my b is a 1, my a is a -2. If I take this 1 and plug it in, I'll get a 3 minus a 2, which is a 1, plus a 5 gives me a 6. If I plug in the a, I'll get a 12 plus a 4 is a 16, plus a 5 is a 21. So I have a 6 minus a 21 over a 1 minus a -2. 6 minus 21 is a -15 over 3. I end up with a slope of -5. So we know the equation will have a slope of -5 already. What we need to do now is figure out the point that goes with it. So the point is going to come from when the derivative of f, which is 6x minus 2, equals that -5. So if I solve for x, I will get a 6x equals a -3, or x is a -1/2. So my x coordinate is a -1/2. And if I plug my x into my y, I will end up getting 27/4. I will trust that you can do the arithmetic to get there. So the equation of my line is y equals x, or -5 times an x plus a 1/2 plus a 27/4. So now let's do the same process with b, which is a trig function. We still are writing an equation of a tangent line, so I'm going to need a point and I'm going to need a slope. And the slope is going to be the secant slope. So that's going to be f of b minus f of a. So that means I'll plug a cosine of pi over 2 in on top. I'll get a 0. Then I'm going to subtract what comes out when I plug in the -3 pi over 2. Well, that's also going to give me 0. So it doesn't really matter what's on the bottom. I'm going to end up with a slope of 0. So to find the point, I need to know when the derivative, which is negative sine, when does that equal 0? Well, sine equals 0 in multiple places, so our goal is to find when in this interval are we going to have sine that is 0. So if we look at our sine curve, it goes like this. And we are limiting our look to, or our hunt, to values between pi over 2 and -3 pi over 2. So I can see that I get a point there and I get a point there where the sign is 0. So that happened when x was 0 and when x was -pi. So I'm actually going to get 2 points. I have a point at 0, 1, and I'll have another point at -pi, so now we got to think about what the cosine of -pi is. Well, think your unit circle. We go -pi, the cosine is -1. So now I can write the equation of my two lines. The first one is y equals 0 times x minus 0 plus 1, or y equals 1. And my second one is y equals 0 times x minus a -pi plus a -1, or y equals -1. So I have two tangent lines coming from this problem. Last one, part C. It's a log natural issue. So same process, we just want to use logs. So we again are going to need a point. We're going to need a slope. We get the slope by doing f of a, or excuse me, f of b minus f of a over b minus a. So 4 is the same as a 2 squared, which means I can bring that 2 in front and get 2 logs of 2 minus 1 log of 2 gives me a log of 2, and on the bottom I have a 2. Now my goal is to find the point that will generate that same slope. So I need the derivative of this which is 1 over x, to equal the log natural of 2 over 2. Well, to solve for x, I can cross multiply and then isolate, or I can just flip both fractions. So I'll get x is 2 over the ln of 2. So I've got my point is 2 over the ln of 2 for my x-coordinate, and my y-coordinate is the log natural of that. So now that I've got my point and I've got my slope, I can write my messy equation of the line, which is the slope times x minus the x-coordinate plus the y-coordinate. And I think I just left it like that. I didn't simplify beyond it.